Uh, Tell me, what all did we do in the last class?
We learned about sizes of triangles and their sizes.
We learned about types of triangles and their
Yeah,
size. Yeah.
yeah.
Okay. Okay. Arna, you can also keep it unmuted. It's just an opportunity for us to kind of recall what we learned before so that we can continue from there. Yeah.
Okay.
Yeah. So you tell me, what else did we learn in the last class?
We learned the shapes, like how to like
So we learned about the triangles, meaning the shapes with three
yeah,
sides. What
triangles,
quad,
squares.
quadrilaterals?
Quad,
Yeah, we quadrilateral is the parent group inside which we have rectangles, we have squares. What else? Rhombus, trapezium. What else? There was one more type.
mm,
Kite.
forgot.
Kite.
Yep.
Yeah. So let's do a quick recap. Let me share my screen first, so that whatever I do here on the screen, you guys can see it. Okay. Let me know once the screen is visible to you. You guys can see it.
Yeah,
Yeah, I can see it.
Can you see the white screen as well?
yeah,
Yep.
yeah, we
One.
can.
Okay. So we talked about. Let me just quickly run through this. We talked about line. We talked about line segment. We talked about rays. We talked about parallel lines and the properties. We talked about angles. Sorry, triangles. We talked about quadrilaterals. Right. Inside quadrilaterals, we learned about rectangle, meaning sorry, this poor guy doesn't look like a rectangle. Okay. We talked about rectangle. We talked about square and the properties. We talked about trapezium. Yeah.
Hmm.
We we talked about we talked about rhombus, which was nothing but a squeezed version of a square. Yeah. We squeezed it from
Yeah.
both. And then we
Yeah.
talked about other shape that you guys would have seen or noticed. This is kite, where these two sides are same, these two sides are same, right? If you look at a square or rhombus, all sides are same length. But kite, though it looks somewhat similar to a rhombus, but the property is different. These are like two pair of sides which are of same length. Okay.
Okay.
So this is what we learned. Then we learned about the angles for a pair of parallel lines, right?
Hmm. Yeah.
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 Now, then we also learned about this magical formula. Yeah. What this
What
formula
is what is this formula for? Is it for finding the total amount of angles?
inside any polygon. So
Okay.
if you are looking at triangle, that means this n stands for the number of sides. So it
Hmm.
becomes three sides. So 2 into 3 minus 4 into
Um,
9.
our teacher said that there's another formula.
Uh, yeah, could be. Could be. I'll come to that. So this becomes 2 into 3 minus 4, 2 into 90, 180 degrees. That we know, right? The sum of all the angles inside a triangle is 180 degree. Likewise, we we can use the same formula for finding angle for other polygons, like we heard something called a heptagon. How many sides does a heptagon have? Do you guys remember?
The heptagon has 7.
Yes. So
Yeah.
if I'm talking about a heptagon, come on. If I'm talking about a heptagon which has, let's say, 7 sides, what is the total angle? I'll just replace this n with 7, and that is what the angle would be. And it can never change. Okay. So this will be the total angle inside a heptagon. So this is 2 into 7, 14 minus 4, 10 into 90, 900. Any heptagon, meaning any shape which has 7 sides, will never ever have angle more than or less than this. Okay. So this is what we have learned so far. Any doubt? Any?
No doubt.
No doubt. Okay. Now, Arnab and Mitran, tell me, where are we with the homework? Were you able to do the homework that was given, or there's something not done?
Yeah, I finished it.
You finished it. How about you, Mitran?
Oh, I didn't finish it.
Oh, okay. Now, see, I will tell you, I am a little different teacher. Okay, little different meaning I don't give homework to my kids to bother them. I give them homework to ensure that my kids are learning the things, or are able to kind of hold the concept with them for long enough. Okay, that's the purpose of homework.
Okay.
Now, what we do differently in our classes, I will give you guys homework after the class. Let's say on Monday, I will give the homework for whatever we are learning today and tomorrow. Okay, and then I'll upload the video also. Then you can use the video to revise what we have learned. Any concept that you that you forgot, that you can refer back by watching the video, and then you try doing the homework. And once you do the homework, you will do the homework and not show it to me. You will show it to one of your parents or somebody, elder to you in the family, and you will not show it, say, okay, this is the homework, this is what this is the homework, just check. No, you will say, okay, this is the homework that I have done, these are the sums that I was given, and this is how I have solved. It's like you're teaching that person. What happens is, when you teach somebody, you can make your concept stronger. Okay, so
Okay.
I'm teaching you guys in a way that you guys can do the same job that I do today, if you want to.
Okay.
So basically, again, just to summarize that, going forward also, when I give you guys homework, you will do that homework to check if you have understood it completely or not, and are you able to do those sums with ease or not. Okay, and if there's something that you're not able to do, you'll come to me, say, okay, this one I did not understand. Even after I watch the video one more time, there's some confusion. Okay, so that gives me an opportunity to explain things in a different or a better way. That is one. And then the homework that you are doing, you have to show it to somebody in the family, explain them what you have done, so that way you are kind of reaffirming your learning one more time by explaining to somebody. Because if you know something and if you're able to explain, that means you have learned. If you
Okay.
know something and you're not able to explain to somebody, that means something needs to be done more. Okay, so that's the formula that we follow here. So going forward also, whenever you are given a homework, do it not for making me happy, it is for you to do it and be sure that yes, whatever you have learned, actually you have learned. Okay,
Okay.
and don't
Okay.
just show it to somebody in the family. So that way your parents also will be more confident that yes, Mitran, Arna has learned something, and they're able to explain. Because if you're able to explain, that means the concept is with you now. Okay, all
Okay.
right. So that is what we'll follow, and I'll keep reminding you guys that okay, did you do homework? This is not to make you feel bad, not to kind of put you on the spot. It is to make sure that you are doing this as a practice. That okay, whatever I learned, let me do some sums. Make sure that those concepts are mine now. Okay, all right.
Okay.
So I will see you guys are uh, you know uh, bigger kids, right? So I by default assume that these kids are more responsible, more sensible, more what do you call, mature. So I will not keep asking you like I do with the smaller kids, but I would assume that if there's a doubt, you'll come to me. Okay.
Okay.
Yeah.
Okay.
Otherwise, if there's doubt, I will anyway take test every month once, right? So then we'll get to know. But yeah, I would want you guys to be more proactive, more open, more transparent with me, so that I would know what you're able to understand, what you're not. Okay. All right. So this is what we have learned so far. And then what else did we do? Did we look at the formula for area and perimeter? No. We just right understanding what is an area and what is a perimeter? Did we?
You're breaking.
Yeah.
Can you hear me okay now?
Not
Is
really.
is it slightly better?
Yeah, you're slightly breaking.
Yeah, I can't understand what you're saying.
Your voice is
Okay.
like kind of like laggy.
Okay. Uh, it's any better now? Or would you want me to drop off and join back again?
It's still kind of laggy.
So it's really laggy for me.
Okay. Okay. So let me do one thing. Let me join from another screen and see what's going on. Let me join again from other screen. Okay.
Wait, can I use the restroom? Can I use the
Sure.
restroom?
Sure. Sure. Uh, okay. Okay. Arna, is it any better now?
Yeah, a little bit.
Okay. Okay. I'm just trying to see if I need to join from another screen or you guys can hear me. Okay. Ah, come on. Come on. What here? Okay. Uh, Mitran, are you back? Not yet. Arna, can you hear me okay now? Slightly better.
Yeah, it's still glitchy, but it's
Okay. I'm just trying to join from another screen. That way. Okay.
fine.
Can you hear me?
You're like it's like I don't know what it's called.
Okay. Okay. Can you hear me better?
Yeah,
It's better now?
yeah,
Wonderful. So, is it fine now?
yeah.
Okay. I did something stupid and that started working. Okay. All right. So, I will, so Mitra, are you back? Okay. He's not back yet. And is there any impact to the voice now with the video being on?
There's no impact. There's no impact.
I'm sorry?
There's no impact.
I could not hear you, Mitra. Say that again.
Uh, There's no impact.
No impact.
Yes.
It's better now.
Yes.
Okay, wonderful. So I've turned off the video actually for from my side. So
Okay.
hopefully that makes it better. Okay, so you guys can see my screen now.
Yeah.
Yeah.
Okay, so did we talk about the area and perimeter? What is it conceptually? Do you guys remember?
Mm,
No.
mm.
Are you guys able to hear me? Okay.
Yeah, we are.
Okay. Now let's quickly touch upon the concepts for area and perimeter. Okay. Let's look at this shape. Okay. Let's say this is my land in my village. Okay.
Mm-hmm.
This is my farming land. What is the area of this land? Area means the space that it takes. This is the area. So this is land. This is a smaller land. Okay.
Okay.
This is a much smaller land. Okay.
Mm-hmm.
baby land. Yeah.
Okay.
So this is taking more space on this surface. This is taking lesser space. This is much lesser space. This is much lesser space. Or let's look at this piece of paper. You see a table here. Oh, my video is not visible. Okay. Anyways, so on this piece of paper, I'm drawing something, right?
Mm-hmm.
This is taking more space on the page. This is taking less space on the page. Yeah. The space that shape takes on any surface is called area. Okay. Now imagine this is the whole village. Okay. This is my village where I have grown up, let's say, in India. Okay.
Okay.
This is the size of the village. Okay. This is my land. Okay. This is my neighbor's land. Okay. Everything is inside the village. Okay. This is my another neighbor's land. So this is mine. This is my neighbor one, and this is my neighbor two. Okay. Okay.
Okay. Okay.
So you here by just by looking at this, what you can make out is that my neighbor two, my second neighbor has a very small land,
Okay.
and my other neighbor one has a land bigger than mine. This is my land. Okay. This guy has bigger land than mine. Yeah.
Okay.
Meaning the area of his land is more than mine. That's how you can relate it in geometry, in terms of geometry actually. Okay. Or you can say the area of my second neighbor's land is smaller than mine.
Okay.
Now, think of this. If this is the land, if this is bigger land, this is small land, this is a big land. Okay. If the area is more, meaning what? You can grow more crops, more vegetables. You can do more things on this land. Yeah.
Mm-hmm.
If this is smaller land, meaning you can do lesser things. You can only put less vegetables. You can only grow less vegetables. Yeah.
Mm-hmm.
Yeah. So area in absolute terms, like we all have houses here, right? So the house in which you live, if the area is more, meaning you have more space, you have more number of rooms. Okay.
Okay.
You have more space to play. You have much bigger kitchen. If the area is less, meaning you have less space, less number of rooms, smaller size kitchen, smaller size bathroom, smaller size backyard also. Okay. So that's how you can relate area. Okay. There's something that you would have probably heard from your parents saying lot size. Okay. If some house has a bigger lot size, means that has a bigger area, meaning you can do more things in that space. You can build more rooms also if you want to. Okay. You can
Mm-hmm.
put more things to play, like the kids shisha and other thing, right? The play area, you can make it bigger, you can put more things. So lot size is nothing but something similar to the way we understand area. Okay.
Okay.
People say this lot size is 7,000 square feet. Okay.
Mm-hmm.
If there's another lot size which says 4,000 square feet, you can make out that this is a bigger land, this has a bigger area, this has a lesser area. Okay. Because this is
Mm-hmm.
4,000 square feet, this is 7,000 square feet. Okay. So
Mm-hmm.
that is how you have to relate area. Okay. This so if I turn on my video just for a little bit, you can see this page. You can see me, right? Okay.
Yeah.
This page has a bigger area, this photo has a smaller area. Okay.
Okay.
You can write more things here, you can write a much bigger letter, you can write smaller letter here, lesser things, less content. Yeah.
Mm-hmm.
So that's what area is. Area means the space taken by any shape in a or on a surface, like we were talking about the land. So land is the space taken by my farm on the surface of earth.
Okay.
Yeah. Clear.
Yeah.
Mm-hmm.
So if somebody says area of this triangle, meaning how much space this triangle needs for being drawn on this piece of paper. area of a square means how much space this square would need on a piece of paper. Area of a pentagon is the space taken by this pentagon on the piece of paper. Okay.
Okay.
Area of a square is the area taken by the square on this piece of paper. Okay.
Okay.
Area of my classroom or the garage where you guys study means how much space do I have? How many kids can sit there? Right?
Mm,
So that is how you will relate area. So area is not a geometrical terms only. It is something that is relatable to our life. We deal with it every day. Somebody says my kitchen is small. That means the area of the kitchen is small. Okay. My bathroom is big. The area of the bathroom is bigger.
okay.
So that is how you relate it with the real life thing. Okay. Now, what is perimeter? Conceptually, perimeter. Let's talk about the rectangle again. Again, go back to my farm. Surprisingly, I don't have a farm in my village. Okay, I'm just making it up. So this is my farm. Okay, in the village. Now, what is the perimeter of this? I know area means how much space it has, how much crop I can grow, right?
Okay.
But what is perimeter? What is perimeter of this farm? Perimeter is nothing but the total boundary here to here. If I start from here, if I want to walk along the boundary of my farm, the total length from here to here, here to here, here to here, here to here. And remember, I'm just walking along the boundary. I'm not going here, 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 and then coming here. Okay. I'm
Okay.
only walking along the boundary. That is what is called perimeter for any shape. Okay. Somebody says, this is, let's say, this is somebody's farm. Okay. Again, I keep on giving the example of a farm. I'm from a farming background. I've never done farming, but I am a farmer's son. So if somebody says, what is the perimeter of this shape of this triangle is, you have to walk along the boundary of this shape. So you'll start, if you're starting from here, you walk from here to here. Once you reach the corner, then you walk from here to here, then you walk from here to here. This
Okay.
sum of all this length is called the perimeter. So if, let's say, if we are talking about a circle, what will be the perimeter? You'll start from here, keep walking along the boundary.
Okay.
You reach the starting point, that is your perimeter. Okay. What will be the area? Area will be what you have inside this. Okay.
Okay.
Any doubt with respect to the concept of area and perimeter?
Mm,
No.
No? Okay. Now let's start playing with the mathematical side of it. Let's say we are talking about a rectangle. Okay. Rectangle meaning we learn the property. Rectangle means the opposite sides are of same length. So this is equal to the length of this guy. This is equal to length of this guy. That is a rectangle. And then every angle is 90 degrees. That is the property we learned. Correct?
mhm.
So if this is the length, let's say, I call this as length and I call this as width. Okay.
Okay.
So if this is length, then this here to here is also equal to length. Yeah. Because
Okay.
because the opposite sides are of same length. Yeah.
Okay.
For a rectangle. If this is my width, that means this side is also width. Okay.
Mm,
What is the area? Meaning a rectangle with length L and width as W. What will be the area? Length
and
times,
times it.
yeah, length times width. Length times width. Yep.
Mm-hmm.
If I ask you guys, and give me a very simple answer, okay?
Okay.
What is the perimeter of this rectangle? You know, this is length, this is width, this is length, this is width. What will be the
Mhm.
perimeter? What did we learn about the perimeter just now? Perimeter of this rectangle. What will be the, how do I calculate the perimeter of this rectangle now?
Length plus. No, you do add all the sides up.
Sorry, say that again.
We add all the sides up.
Uh-huh. So that will be,
it would be, wait,
I am a very simple person. Okay. I will do the math in a very simple way. So let's say this is a perimeter, right? I will start from here, travel the entire rectangle along its boundary. From here to here, what is my length? L.
Okay.
We'll go from here to here. What is this length? This is called W, right? I'm just adding it. I'm going from here to here. What is that value? Length. I'm going from here to here. Basically, I started from here. I traveled from here to here, here to here, here to here, and then came back to the final point. Yeah.
Okay.
That is my perimeter. Yeah. So
Mhm.
I did length plus width plus length plus width.
Mhm.
That means I have 2 times of length plus 2 times of width. Yeah.
Mhm.
So I have one length and one more length, right? It's like one banana and one banana, two banana, one apple and one more apple, two apple. So two bananas and two apples. So 2 times length plus 2 times width. Yeah.
Mhm.
I can also say this as 2 times of length plus width. Do you guys agree?
Yeah.
Yeah. So this is my formula for the perimeter of a rectangle. We did not do anything magical. We did simple things. Math is all about simplicity. Okay. So this is my rectangle. This is the length. This is the width. What I know is for a rectangle, the property is that opposite sides are of same length. So this is length. So this will be length. This is width. This will be width. Now area is length times width. This is simple.
Okay.
Length times width. Perimeter is 2 times length plus width. And why? Because we just derived this. We just added this one and this is what it became.
Mhm.
Yeah.
Yeah.
So see, so far we have not done anything complicated. Yeah. We just
Yeah.
understood the concept of area and the concept of perimeter, and we are just trying to reuse that concept to derive this formula. Okay.
Okay.
Now, after this class, what you will have to remember is okay, area of a rectangle is length times width. Okay.
Mhm.
And perimeter is you can either count by yourself or you can remember this formula. It's up to you. Okay.
Okay.
Now let's look at another shape, square. What is the property of a square? All sides are of same length. If this is length, this is also length, this is also length, this is also length. Yeah.
Yeah.
Now, and also I remember I kept on telling over and over again that square is nothing but another type of rectangle.
Yeah.
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 Where the sides are of same length. So this is also a rectangle only, and the opposite sides are of same length. But
Mhm.
here the only difference was length and width are also same. So this is equal to this is equal to this, and this is also equal to this. These two also same. So that's how all the sides are of same length. So
Okay.
it has all the properties of a rectangle. So we can reuse the formula of rectangle in a square as well. What we will do is everywhere we have length and width, we'll just make it length because length and width are same here. Yeah.
Mhm.
Am I making sense so far?
Yeah.
Yeah.
Yeah. So the
Yes.
area of a square would be same as area of a rectangle. So length into width. Here my width is also equal to length only. So this becomes length square. Okay.
Okay.
Perimeter of a rectangle of a square would be same as rectangle, right? It has all the properties of rectangle. I will use length. Wherever I have width, I don't have separate width. My width is same as length. Okay. So this becomes 4 times L. So I'm giving this option to you guys, whether you want to remember this formula separately or you want to remember only one formula and use the property of a square to derive this formula at runtime. Okay.
Okay.
Yeah.
Yeah.
So area of a rectangle becomes length into width. Perimeter is 2 times length plus width. Area of a square is length square, meaning length into length. Yeah. The same exponent thing that we learned before. Length into length is square. Length to the power 1 plus 1, 2. Yeah. And then perimeter will be equal to 2 times length plus length, or it becomes length plus length is 2 length, right? 2 times length. So that is 2 times length into 2 is 4 times length. Yeah.
Okay.
So you guys can choose how you want to remember it. And I would in fact suggest don't even remember it. Just do few sums and then you'll remember it without putting any effort to remember it. Okay.
Okay.
So far clear?
Yes.
Yeah.
Now let's look at. Okay, before I go further, do you guys know what is SOHCAHTOA? No? Okay, forget it. We'll learn it.
Okay.
Mithun, you were saying something?
No, I said, what did you say?
Do you know what is SOHCAHTOA?
So Katua, no.
SOHCAHTOA is sine, cos, and tan. Do you know this?
No.
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 Don't worry about it. I'll go step by step and make it like a cakewalk. Okay, don't worry. Now, so far we have learned about the area and perimeter for rectangle and square, how to derive the formula, right? So tomorrow, if somebody says you have a rectangle with length as 5 centimeter and width as 2 centimeters, okay, find out the area. Very easy. You know that area is length into width. So you'll say 5 centimeter into 2 centimeters. That becomes 5 into 2, 10 centimeter into centimeter is centimeter square. Yeah.
Okay.
If somebody says, okay, find out the perimeter of this guy, you also know that perimeter is 2 times length plus width. So you will say 2 times length is 5 centimeter plus width is 2 centimeters. Okay. So 2 times of 5 plus 2, 7 centimeters. Okay. That is 14 centimeters. Done deal. So basically,
Okay.
once you know the formula, just read the question and we'll do some sums. Don't worry about it. Okay. Now let's look at one. So we talked about triangles, right?
Mhm.
We talked about classification of triangles also. That you can classify the triangles based on sides or based on angles. Correct?
Okay.
If the sides are of same length, that is called equilateral triangle. Yes. If two of the sides are same, that is called isosceles triangle. Yeah. And if all the sides are of different length, that is called scalene triangle. This,
Okay.
Okay.
this, is, this is one type, right? One classification based on sides. Now the second classification was based on angles, right?
Uh-huh.
Every triangle has three angles, correct?
Mhm.
If one of the angle is greater than 90 degree, this is called what type of triangle?
That's obtuse triangle. Obtuse
Obtuse,
angle.
obtuse triangle, correct. If one of the angle or all the angles are less than 90 degree, what is that called?
Acute angle.
Acute triangle.
Angle.
Acute angle triangle or acute triangle, whatever you want to say.
Mhm.
Yeah. And the third one is, I will ask Arna to answer this one. Do you
Okay.
remember, Arna, what is this one called?
Um, this is not right
R-
angle.
Yes, this is right angle triangle. Okay.
Okay.
So here the request that I have for both of you. Whatever you say it loud and clear. It's okay to make mistakes. Okay. In my
Okay.
So when you think, oh, is this right? Is this not right? That is where even if you're right, you will doubt yourself and bring your confidence down. I don't want you to do that. Okay.
Mm. Okay.
Even if it's wrong, just say it loud and clear. If it's wrong, I'll correct it. Don't worry.
Mhm.
Yeah. Anna, okay?
Yeah.
Yeah, okay. So what I was saying was what you said was right. You were spot on with the answer. Just that you're saying it low because you were thinking twice. Is it correct? And you were actually correct. Okay. So a right angle triangle is a triangle where one of the angle is 90 degree. Okay.
Okay.
That is right angle triangle. Now, why I'm stressing on this triangle? This triangle is the culprit of lot of problems in life.
Mm-hmm.
Why? Because this triangle has defined a new subject altogether in maths called trigonometry.
Okay.
Okay. So, more you know about this guy, this right angle triangle, more comfortable you will become with trigonometry in future. Okay. And
Okay.
trigonometry is one of the important subject and one of the interesting subject that you will deal with in your SAT also. Okay.
Okay.
So
Okay.
that's why I want you guys to become friends with this triangle. Okay. This is
Okay.
nice. This is called right angle triangle. Okay. And do
Okay.
you know how this triangle is born? Wh- This triangle was born when somebody just split this rectangle into two parts, meaning they joined these two vertices, okay,
Mm-hmm.
of a rectangle, and whatever
Okay.
was no, whatever was built, that was called right angle triangle because you have a 90-degree here.
Mm-hmm.
So the clue that I'm giving you guys is that a right angle triangle was born by joining the two vertices of a rectangle. Okay, what
Okay.
is this called? Length. What is this one? Width. Yeah,
Okay.
this is 90-degree. If you look at it carefully, this diagonal is actually splitting this rectangle into two parts. Yeah, two
Yeah.
equal parts. Yeah. So
Yeah.
whether you divide this rectangle this way or join these two corners, you're actually splitting into two parts. Look at this triangle now. Okay. See here, what did you do? You joined this corner with this vertices. These two vertices you joined. What became? This right angle triangle, this right angle triangle. Yeah.
Yeah.
And these two are actually mirror image of each other. They are equally the same because this side and this side are same, this side and this side are same, and this side is anyways common. And this angle is 90-degree. So actually, if you look at this triangle and this triangle, just by joining the opposite corners, you are splitting this into two equal triangles. Okay. Now, what does it mean? If somebody says, what is the area of this right angle triangle? What is this area? If this is length, this is width. It will be half of the area of a rectangle. What is the area of a rectangle? Length into width. Yeah. Let me make it more clear for you guys. This is a rectangle. Yeah. I'm joining these two corners. Okay. What this corner does, this splits this rectangle into two parts. This is one part and this is another part. Yeah. Are you guys with me?
Yeah.
And these two parts actually
Yes.
same. These two parts actually same. So by joining these two vertices, you split the rectangle into two parts. The whole area of this rectangle it got divided among two brothers actually, or two siblings.
Okay.
So the area of this triangle is half of the area of this whole rectangle. Okay. So this is half of the area of the rectangle. Area of rectangle is what? Length into width. This is what we
Okay.
learned. Yeah.
Yeah.
Half of the this into this. This is length. This is width. Yeah.
Mm-hmm.
Yeah.
So that way, now what you know is any right angle triangle that you talk about is actually you can visualize this as a as a half of this rectangle that you can make with this.
Mm-hmm.
Okay.
This
Okay.
is half of this into this. So if this is, let's say, A, this is B, you'll say half of A into B. This is your area. Area
Okay.
of right, area of a right angle, area of a right angle triangle. Okay, this is right angle triangle. This is 90-degree. Let's call this as a base. Okay. and let's call this as a height. Okay, this looks like this is tall. This is the height of the triangle, right? Let's call this as base. This is height. So area of this is half of base into height into this length.
Okay.
So you have to visualize this little bit. Okay, this is how did we derive the area? So area for right angle, how is a right angle triangle born? Right angle triangle is born by joining the two corners of a rectangle. Okay, this is right angle
Okay.
triangle. This is 90-degree, and that divides this whole rectangle into two parts. Meaning, if this area is length into width, this into this, right? So this area is half of that. So half of length into width. That is what it will be. Very simple.
Okay.
And this length is one side of this 90-degree and width is other side of the right 90-degree. Now, whatever you call this side, right? That you will just multiply these two sides. That is what will be the area. Let's do some sums, okay? Let's say that I have a right angle triangle. Okay, this angle is 90-degree. 90-degree. Okay. This length is 5 centimeter. Okay. And this is
Okay.
3 centimeter. Okay. What is the area of this triangle? Area will be, first thing I will see, okay, let me see the property. It's a right angle triangle. One of the side against the 90-degree is 5 centimeter. This one is 3 centimeter. So area will be half of this side, which I can call as base, and this side, which is height. Okay. Half of 5 into 3. This is 5 centimeter, 3 centimeter. So this becomes 5 into 3, 15. 15 by 2. This is centimeter and this is centimeter. So centimeter into centimeter is centimeter square. Okay. Now,
Okay.
somebody says you have another right angle triangle with side as 3 centimeter, 4 centimeter. Or
Okay.
let's say 4 meter. Okay. And 3 meter. So what will be the area? Half of this base and this height. Okay, I'm not looking at the slanted side. Okay, I'm only looking at the perpendicular sides, this side and this side. Half of base, I'm calling this as base, 4 meter into this is 3 meter.
Okay.
So then I can do tic-tac-toe, right? This 4 becomes 2 into 2. So I can say, okay, this 2 and this 2 will be gone. This 2 and this 2 will be gone. So I have 2 into 3, 6 centimeter square. Yeah. Sorry, this is 6 meter square. This because my unit is 4 meter here and this is 4 meter here, 3 meter here.
Mhm.
Yeah.
Mhm.
So tell me one thing before I move forward. I can sense you guys are not very comfortable with whatever we have learned so far with triangle, right angle triangle. Is that a true statement or I'm just making a wrong assessment?
Um, we're comfortable. We're
Yeah.
fine.
I'm sorry?
We're
You're fine.
fine.
You're fine? Okay. Arna, you're fine too?
Yeah.
Okay. Then I'm comfortable. That's why I keep no kind of poking you guys to say things loud and clear. When you say it loud, that makes me believe that yes, the kids are following me. Okay.
Okay.
So no doubt with right angle triangle also. Correct?
Yeah.
Mhm. Yeah.
Now let's say this is 3 centimeter, this is 4 centimeter, and this is my right angle triangle with 90-degree here. And this is 5 centimeter. Okay. Area you will be able to find, right? What will you do? You will look at the sides along this 90-degree. This is one side, this is the other side. So you'll multiply half with this side, which is 4 centimeter, and then you'll multiply this side 3 centimeter. So this becomes 4 into 3 by 2, meaning 12 by 2, 6 centimeter into centimeter, centimeter square. Okay.
Okay.
Now, what about the perimeter?
Wait, what? Can you repeat the question?
So I have a right angle triangle with one side as 3 centimeter second side is 4 centimeter, third side is 5 centimeter. What will be the perimeter of this right angle triangle?
Uh,
So let Arna think and tell me. You also keep thinking about it, Mitran. I'll come to you. Let Arna complete.
okay. Can you say the numbers again?
3 centimeter, 4 centimeter, and 5 centimeter.
Okay.
And as I keep saying, math is the easiest of all subjects. Let's see what Arna says.
Um. Wait. So I'm trying to find the what?
Perimeter.
So I forgot. I don't know.
And you will laugh at me once I explain it one more time, okay? This is very easy one. And I just think, you guys are probably thinking just too much, okay?
Okay.
What do you say, Mitran? What will be the perimeter? If I know I have a right angle
Is
triangle.
it 3 times 4?
Nope. Perimeter. Recall what is perimeter.
Um,
The border, like all around.
Yeah. You're getting there. Now tell me, what will be that?
are you
Mit-
asking me or her?
Oh,
Uh,
is it 11
3 plus 4, 7 plus 5.
plus
Mm.
5? How is that 5? I thought that was a 4.
So 3 plus 4, 3 centimeter, 4 centimeter, and 5
Oh,
centimeter.
I thought you wrote a 4 on the thing above. I didn't see that.
Okay, so you're saying that it will be 3 plus 4 plus 4, 5? Is that what you're saying?
Yeah.
Okay. Mitran, do you agree?
Yeah.
Yeah. So see, again, as I'll repeat myself. Whenever you get a sum, always think that this is one of the easiest thing that you have to do. Meaning, don't overthink, okay? Because that's where the chances of going wrong is more. Now, whenever I say perimeter, what did I say? Perimeter is the total length of the boundary. So you start from here, keep walking along the boundary, reach to the place where you started from.
Okay.
This is a right angle triangle. Okay. What is the perimeter? Perimeter is no magical stuff. You start from here, measure this length, measure this length, measure this length till you reach to the starting point. You're just walking along the boundary. So you'll just add all the sides, and that is what your perimeter is. Okay. So there's no formula for a perimeter for a triangle. Okay. That you have to remember. You have to just find out what all the sides are. So Arna, what you were doing was actually right. Okay. So 3 centimeter, 4 centimeter, and 5 centimeter. You just added them together. 3 centimeter plus 4 centimeter, 7 centimeter plus 5 centimeter, 12 centimeter. Yeah.
Mm-hmm.
If somebody says there is an octagon, okay, let me see if I can draw an octagon. No, wait, 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 wait. I'm just making an attempt to draw an octagon, okay? So let's say this has 1, 2, 3, 4, 5, 6, 7, and 8 sides, okay?
Okay.
Let's say it was here like this. If somebody says, find out the perimeter of this octagon, okay? Trust me, nobody will give you a formula for finding the perimeter for octagon, okay? Only thing you have to worry about is find out the length of all the sides, okay? There's no formula for this. So you will just say, okay, perimeter means the total length of the boundary. It's like a wire, the length of the wire that you need for barricading this whole place, okay?
Okay.
For any shape, be it a triangle, be it a rectangle, be it a square, be it a rhombus, whatever it is. You just find out all the sides, add them together, okay?
Okay.
If it's a circle, it will be the length of the entire string that can cover the boundary of this, okay?
Okay.
So if you come across any perimeter question, okay, always think, okay, do I have the length of all the sides? Add them together. You're done. Okay. No formula. So we were doing it with rectangle because we knew, okay, this is the length, this is the length, this is the width, this is the width. So this length plus this length, 2 times length. This width plus this width, 2 times width. So 2 times of length plus width. That is what the formula was. But in simple terms, you were adding this length, this length, this length, and this length. As simple as that, right?
Mm-hmm.
Similarly, for a square, you were knowing that all these sides are same. So you were saying 4 times the length, meaning this length plus this length, 2 times the length. This length is 3 times the length. Adding this becomes 4 times the length. Yeah.
Mm-hmm.
Perimeter doesn't essentially require us to remember the formula. You have to just add the sides. Okay. Except for circle, which we'll learn in the next class. So far, let's do a quick recap. What all we have learned.
Okay.
Okay.
We have learned the different shapes, like the triangles and the properties that we did in the previous class. We just did a double click of that today. We learned about the the shapes, the area and perimeter conceptually, what it means. Then we tried deriving the formula for area and perimeter for rectangles and squares. Yeah. And then we derived the formula for the area of a right angle triangle. Okay.
Okay.
We'll do some sums with these three types of shapes. Then in the class tomorrow, okay, and then after that we'll go to the few more formulas that we need to learn for area of any type of triangle, area for a rhombus, area for a trapezoid. Once
Okay.
we will be clear with the area and perimeter for the basic shapes that we need to know, and then we'll go to circle. Basically, in tomorrow's class, we'll do area for triangle, area for trapezoid, area for rhombus, and area for circle. These four things we'll do. Okay,
Okay.
and we'll try doing few sums with area of rectangle, square, and triangle, right angle triangle first, and then we'll go to this one. So we'll not do tables. We'll not do a recap of what we have done in the previous class, but we'll focus on learning these four things so that we can kind of try doing more sums, and then make our understanding to an extent where we can deal with all the basic types of shapes, when it comes to area. Okay, area and
Okay.
perimeter. Yeah. So that brings us to the end of the class. Any questions you guys have? Anything
No.
that you found complicated, boring, tiring?